All right, let's get going with 8.4. And so in 8.3 we learned about logarithms, and in 8.4 we're going to expand on that with the properties of logarithms. So no new vocab today, we're just dealing with logarithms, and we're just going to learn how to use the properties of logarithms. It's a pretty straightforward section. Before we get into that, let's do our skills check. Number 1, log base 2 of 4. 2 squared is 4, so log base 2 of 4 turns into 2. Plus log base 2 of 8 is 3, because 2 cubed is 8. So the answer for number 1 is 5. And I'll do number 4 as well. X cubed minus x if x is 3. So 3 cubed minus 3 is 27 minus 3, which is 24. Plug in x for those. All right, pause the video, take a second, and go ahead and do 2 and 3, and then 5, 6, and 7. It looks like this got cut off here. This is an x right here, x to the 9th. All right, so do those. When you're ready, press play. We'll get going with 8.4. Okay, so these are the 3 properties you need to know. Write them down in your notes. Pause this video if you need an extra second. The product property, if you have the log base b of some number times another number, or some variable times another variable, something times something else, we can split it up into 2 separate logarithm problems. Log base b of m plus log base b of n. Same goes for dividing, but when we split it up, we're going to get subtraction. And then anytime you have a logarithm problem where you have an exponent at the end, we take that exponent and just bring it out into the front and have it be a multiplier, x times log base b of m. So that's the product property, the quotient property, and the power property. Have those down, and let's try to use those for example 1. Which property are we using? Okay, so log base 2 of 8 minus log base 2 of 4. We can combine these and get 8 divided by 4 and get 2. So that's the quotient property. Let's see what else we got here. Log base b, we're going to take x cubed and split it up into x cubed, and then plus the y. So we're actually doing 2 things. The plus right here, splitting them up, is going to be the product, and then bringing the 3 out in front, and the power rule. All right, so we're using 2 different rules on part B. See if you can do the same thing and tell me what properties are used for the first understanding check. Okay, example 2. Write each log expression as a single logarithm. So we're going to put these together. All right, so the thing that has to happen to be able to put them together is we have to have the same base. So since we have 3 and 3, we can do this. Since we have 2 and 2, we can do this. If it's a minus problem, we can combine them into a single division problem. 20 divided by 4. And we'll go left to right. 20 on top, 4. Whoa, why did I write 5? 4 on the bottom, okay, as your second number. We can simplify that as log base 3 of 5. Same reasoning here. We can say first things first. We're going to take the 3 and put it back on top. So log base 2 of x cubed plus log base 2 of y. So we've used the power property so far. And then the plus means we can combine them into a single logarithm where we're multiplying together. X cubed y. Single logarithm problem, log base 2, x cubed y. Your turn. See if you can do understanding check 2. All right, now we'll go the other way. We'll expand them. We'll start from a single and make them multiple ones. So this is a division. We'll use the quotient property, log base 5 of the numerator minus log base 5 of the denominator. All right, we've got multiplying in here, so we're going to expand it with addition. Log base, don't see anything, so we'll say 10. We don't even have to write the 10, but we know it's a 10 down there. If we don't see anything, we assume it's a 10. Plus log of r to the 4th. And then we can bring that 4 in front of this one. So it's going to be log 3 plus 4 log r. That would be your expansion. Your turn. Understanding check 3. All right, last part of this pretty straightforward short lesson here today, 8.4. All right, so we use logarithms to model sound. The intensity of a sound is a measure of the energy carried by the sound wave. The greater the intensity, the louder it seems, but it's not related one-to-one. It's an exponential function, and here we go. The loudness in decibels is given by 10 times the log of I over I0, where I0 is the lowest sound the human ear can detect. So this is the equation we need. L equals 10 log I over I0. We're going to use that on number 4. So I'm going to write down that equation real quick before we forget it. L equals 10 log of I over I0. All right, so let's read our word problem here. A shipping company has started flying cargo planes out of the city airport. Residents are getting upset, and so the shipping company wants to hire you to design a way to reduce the intensity of the sound by half. All right, how many decibels would the loudness of the sound be decreased? All right, so here's how we're going to go about this. I'm going to use subscripts here to figure out when we're talking about which loudness. So at the beginning, I'm going to call the loudness L1 and the intensity of that sound I1. All right, and then I'm going to say I want to end up with an intensity that's cut in half and figure out the loudness there. So L2 is going to be 10 log I2 over I0. But we know that we want to get I2 cut in half, right? So I2 needs to be half of I1. So we can say 0.5 of I1 over I0. Okay, so what we want to do here is we want to change things, right? We want to have a change in the sound, right? This decrease word. So we're going to decrease from L1 to L2. So let's set this up. L1 minus L2 is what we try to do. We're going to use our substitution, and instead of L1, let's write 10 log I1 over I0 minus L2. L2 is 10 log 0.5 I1 over I0. Okay, so once you get to here, it's a little tricky getting to here, but once you get to here, we're going to use our rules of expansion to clean this up. I'm going to take this 10 and put it out front, so we don't have to worry about these 10s anymore for a while. And let's just deal with this first logarithm right here. We've got division, so we can expand this. So we're going to say log I1 minus log I0. Okay? And then we need to minus this whole thing here. We're going to minus, let me put parentheses around each part here just so we can see what's going on here. Minus the log of, now we're going to multiply the top, so log of 0.5 plus the log of I1 minus the log of I0. Oh, bunch going on here, but luckily some things are going to cancel out. Log of I1 minus log of I1 goes away. Log of I0 plus, because this negative would distribute in there, make it a plus, that's going to cancel out. And let's see what we've got here. We've got 10 times the negative log of 0.5. Let's plug this in and see what we get. To the calculator we go. 10 times the negative log of 0.5. Now we can do this on our calculator because it's base 10. That's what this button is, log base 10. So we'll go ahead and hit enter, and we get 3.010, and we'll say how many decibels, so we'll round that off to 3. We need to decrease, the sound would end up being decreased by 3. 3 decibels is what we decrease. All right, so you need to use the same thinking here. Oh, looks like it froze it. Let me see if I can pause this for a second until it unfreezes. There we go, we're back in business. All right, your last one here is to do understanding check 4. We want to reduce the intensity of sound by 25%. So it's the same setup, right? Use the same setup that we did here, but instead of cutting it in half, we're decreasing it to 25% of the original intensity. All right, try that problem. We'll go over it in class. Good luck with this, and that's all there is for 8-4.